screen out through the meeting. Got slides on the wall here. So, good morning. My name is Andrew Stivers. I'm one of the instructors here with Sunset Learning Institute. We're doing our quarterly tech talks. And one of the things I wanted to talk about today, from a security perspective, is 802.1x authentication for Cisco APs. So this is not something that I get asked about a lot. That's where most of my tech talk topics come from. Is there questions I get in class that I want to address? Just create a video just so we have that forever. But this is something that's becoming more and more important as wireless becomes more and more important. So let's jump in here. So what we're going to look at is the actual configuration. All right, it's actually not that hard. It's a little bit of work, all right, but it's not hard any these days to set up 802.1x authentication on your controllers, your Radius server, and the switches between them. All right, so why do we care? All right, why are we talking about this? Because if you don't do this, all right, the default is that a Cisco wireless LAN controller will allow any access point, any of your AireOS APs, to connect, associate, and become part of your wireless network. So what we're kind of concerned about are, one, malicious access points, and two, Bobs. All right, if you have taken any training with me, I like to reference Bob as our theoretical employee who has good ideas. All right, we don't like that. So the focus, this is going to be for everybody who's a network administrator, everyone from a security perspective, wireless perspective, where we're dealing with our day-to-day deployments, making sure the wireless is working, but we're also protecting ourselves from those possible problems. Let's talk a little bit about the why first. All right. So yeah, we'll talk about the why, the how, and then get to the actual configuration. So why is this so important? Why do you care? Wireless is more than mission critical these days. All right, so there's the critical apps, there's the wireless, the forklifts, the scanners, the barcode scanners, and Wi-Fi is critical for all of that. But we're starting to see, there's always an exception. It's been around for a couple of years, but we're starting to see a bigger trend of new networks using wireless as the method of access for all devices. So that we've had a number of students, number of deployments and companies where they're looking at providing power. Right? Everyone needs power, get a little outlet up there, cubicles, the desks, and that's it. There are no wall drops. There are no Ethernet cables planned. There's not even going to be in the wall for future deployments. It's wireless. That is the method. So, okay, as that trend continues, your employees get the idea, all right, it is wireless access. Everything we do is wireless, which is great. You're not tied to a cable. But then what if the coverage isn't that great? There's a cubicle in the corner of the building, or someone, they got the C-suite, they got the corner office, and the coverage isn't quite great there. All right, so that's where we start looking at needing to optimize. Also, from a planning perspective, every deployment is now high density, quote unquote. So back when wireless first started, we had coverage optimization models. You made sure you had enough APs covering your office. And then for the couple wireless users that were out there, maybe the early 2000s, the couple wireless users, no one was using wireless like we use it today, that was enough. And then we had a couple more wireless users. Now everyone's got a laptop, a cell phone, probably a tablet on top of that. So what constitutes a high density deployment is more than one connection every 120 square feet. Think about that for a second, 120 square feet. More than one connection. That's every single cubicle these days. That's every single company. So from a planning perspective, we're looking at there are dozens of connections in any given coverage zone. Why is this important? Your APs might start getting overloaded. if enough clients, if the connections aren't being spread out, we've got all of these wireless clients. Everything's a wireless client getting there. And so if an AP is getting overloaded with connections, it's not able to serve those clients well. So that's where Bobs start coming into play. So Bob, in this example, is your theoretical employee who he's read a couple articles about Wi-Fi and maybe subscribes to Popular Science, Popular Mechanics magazine, if those still get printed. And so he says, oh, Cisco APs, you can just plug them in and they will automatically find. They got all these different search options. He's kind of technical and just enough to be dangerous. We've all got an employee like that. And so Bob goes out, purchases an AP, plugs it into his cubicle. Because it says, I know there's an AP here. I know it's serving this area, but it's not doing enough. I don't have a good connection. My quality of life, or a QoE, quality of experience, is not great. So I want to optimize that by providing another wireless access point. That'll help, right? But we know if you throw too many access points together, they can just contribute to interference. More APs is not always just a good thing. So we protect ourselves from the Bobs, so that anyone just throwing an AP trying to add more coverage doesn't actually do that. All right. But then of course there's the malicious actors. They know we are using wireless, and they also know how Cisco APs work. So what they can do is you take a Cisco AP and you load your own code into it. They're taking Cisco code and they're adding in malware, so that when the AP plugs into your network, goes through the normal discovery process, finds your controller, synchronizes, downloads the configuration, but it's also running the malicious code. And so the attacker is scraping information, trying to push their information up to the controller, trying to retrieve information from the controller through that malicious AP. So we want to make sure that's not just the good ideas, but also potentially malicious access points are not allowed to join the overall wireless network. All right, so that's why we're doing this. And in another 2-3 years, as wireless is again becoming more and more important, 5 years from now, we have 5G cellular networks. We got the new 802.11 wireless protocols. This will start to become standard issue. Everyone's going to start doing this because it will be so critical. For now, it's kind of optional, but just get used to this. It's going to be important. More important than it is today. All right, so how does this work? You got your APs. We are obviously plugging them into our switches. Depending upon your deployment, there's a number of options. You could have an AP plugged directly into the wireless LAN controller itself. When we look at Cisco's iOS XE deployments, they are converged deployments. That's where you could have an AP plugged directly into the switch that's acting as a wireless LAN controller. In other environments, you could have a controller in a centralized location. It could be iOS XE, it could be an AireOS controller. So you have the controller in a central location and just regular switches, regular catalyst switches out around the environment. So that's what we're kind of looking at here is if you have the AP plugged directly in the controller, that's great. You don't have to worry about authentication. You're authenticating, setting up an identity. You don't have to worry about setting up a separate server. You're authenticating on the controller right there for every AP it's talking to, it's every APT it's touching. What we're looking at here is, okay, if you're not doing that, if you just have a switch that your AP is plugged into, you have a large office building and all these switches, and so with a centralized controller, how do we lock that down? What we're going to use is a radius server, so centralized authentication. We'll create our credentials, we'll create a policy for authentication, and we're going to point the authentication traffic off to that controller. And so with the authentication, excuse me, we have options. We can use EAP, your extensive authentication protocol. We can use EAP TLS, the transport layer security. You got PEEP, your protected EAP, and of course EAP Fast, using the LSE, the locally significant certificates on your APs. You all might remember the different flavors of EAP. EAP TLS, we have both server and client-side certificates for the authentication. So in that case, we have the locally significant cert on the AP the cert on the Radius server for authentication. PEEP, protected EAP, you've got server-side certificates, client-side credentials. That's what we'll look at in the configuration here. It's a little easier to set up, less work for you and I on a day-to-day basis. And of course, EAP fast using that PAC, the protected access credential, where there's no certificates, but it's pre-shared keys, which are master key on both sides. So we're going to take a look at using PEEP, one of the easier ways to set up, because we'll have our Radius server. We'll use Cisco ISE in the example. And that's going to have its server certificate to hand out. But then on the client side, we're going to create credentials that these credentials have to have in order to join the network, in order for that port to go live. Excuse me. There are a couple limitations here. So if you're setting this up, you can't do this on a dynamic port. All right, a port that's dynamic auto, dynamic desirable. So you can do this on static trunk ports, you can do this on static access ports, that's fine. But that's usually what we're going to have anyway. We'll manually set those from a security purpose, but you can't do it on dynamic. It's not supported on mesh mode APs. Why does that make sense? It's not plugged into a switch. With mesh mode APs, the whole point of mesh is it's wireless client connectivity and wireless backhaul. You got an AP with power, but there's no switch that it's plugged into. And those are absolutely functional, fully functional today. But we only use those if we can't get them a switch. All right, that's so ballrooms, outdoor environments, industrial environments, any water environments, if there's boats involved. If there's no physical connection, no wire, then sure, mesh mode works. But because we're using the switch to aid this authentication process, this AP authentication doesn't work if there's no switch. And a couple of limitations there. Anytime we're changing the environment, if you clear the AP config, you update the certificate, if you misconfigure this, then you have to start over. All right, you fix the config and you're restarting the authentication process with that new information. So just keep that in mind. We try to do this correctly, all right, because if we don't, we have to start over. All right, it can't recover from any of that. It can't automatically rejoin, renew. We have to start over from the beginning because this is the authentication before anything else takes place. All right, so let's get in. How do we do this? So first off, we need to set up the switch to use AAA, to enable AAA authentication, and we'll enable it on the port. So this is the switch, the Radius server setup. We're telling the switch that the Radius server exists and who to send the credentials to. So we'll say AAA new model, turn on AAA services. This command, it's usually in there, .1x system off control, but what I've been seeing is depending upon which Cisco design guide, which Cisco reference guide you read, it's not always there. So double check when you're doing this deployment, double check which version, which model of switch, which model of code, which version of code you're using, whether you need the .1x system off control command, enabling you to 1x control. We're going to define a AAA authentication group. We'll say AAA authentication .1x default group radius. We're going to be identifying our radius group to authenticate. Got that in there twice. And then we identify it that there is a radius server. There's a radius server, give it a name, what's the IPv4 address, put in some authentication, accounting ports, plug in the key, super strong key. Don't actually use that as your password. The shared radius, the shared secret between the switch and the server. So we're just telling the switch, turn on AAA, that's your radius server for authentication. We then go to the ports. All right, so this could be on the interface range command if you have multiple interfaces. It could be just on one interface that we're setting this up. So it's a little faint on the wall here, but I am sharing the slide out to the meeting. So we'll throw the port in the correct VLAN, whatever VLAN the access port, whatever VLAN the access point is going to get an IP address in. And we're going to set it manually as an access port, switch port mode access. So again, you can't do this on dynamic port, so you have to be either manual trunk, manual access, or an access port. we're going to turn on the authentication. So it's authentication order .1x. So if you wanted to, you could fail over to local. We're just saying use 802.1x authentication. We're turning on the authentication port control based on 802.1x. And then we're saying the .1x PAE authenticator, again, giving priority. Those three, doesn't really matter what order you're doing it. You're enabling 802.1x. You're setting it up to just point off to the radius server. Kind of optionally, they're saying spanning tree port fast edge. That's a recommendation from Cisco. This is an edge port. This is a client-facing interface, even though it's an AP. And so when we plug in that interface, you want it to come online immediately, not wait the 30 seconds, go through the listening, learning phases with spanning tree. So we're enabling AAA, putting in the correct VLAN. So when we plug in a device here, before the port goes live, we will allow the 802.1x traffic, will allow authentication, and then if the radius server says, yes, this is a valid device, then the port will allow all the traffic. All right, so now we need to create the credentials. Like I said, we're going to do PEEP, the protected heap, so server-side certificate, client-side credentials. What we can do is we can install the credentials on the controller to hand those out to the APs. We can do controller-based AP authentication or radius server-based authentication. Either one is fine. So here on the AireOS controllers, you can see the path they give you here. Under wireless, under the general tab, when you scroll down, you'll see the 802.1x supplicant credentials. And so we'll use that one checkbox. We'll enable, we are doing 802.1x authentication for the APs. Then you create the username and password that you want your APs to be using. If anyone's using iOS XE, this is an example from one of Cisco's, the newer 9800 controllers, where they do it under tags and profiles. This is just me. The terminology is a little interesting to get used to with Cisco's 9800s with their iOS XE deployment. Tags and profiles is where you start defining some policy elements, what gets used to identify wireless LANs, what locations those wireless LANs are deployed at. So it makes for a very scalable configuration, just the terminology is not always the easiest to get used to, just keep that in mind. So here under, we'll create an AP join profile, and our management credentials, we'll start creating some 802.1x credentials. So again, you're looking at, excuse me, on the controller, creating the credentials that all your APs are going to use. So then we need to tell the identity service engine, tell your radius server, that this switch is going to be providing device credentials, so we're identifying about this network device. So on that ISE engine, under administration, network resources, network devices, I gave you the path there, we're going to create a new network device. So this is just our switch, we plug in the IP address. Down here, we do that same radius shared secret. So we took the switch, you point at the radius server, take the radius server, pointing it at the switch, saying you two will be exchanging 802.1x information. All right, so now the radius server will respond when that switch is presenting the credentials, saying is this a valid device? We then start creating the AP identity and identity group. So with ISE, it's a wonderful tool, but it's too wonderful. All right. The reason ISE deployments sometimes take 8 to 9 months is because you can configure everything from a security perspective on that identity service engine. And it's a very scalable, very granular configuration. So that's what we're doing here. By creating these identities and these identity groups, this enables us to reference that in different policies and have very scalable policies for any kind of future configuration. We don't want to just blunt force, say, username, password, it's the user, go. We're gonna put it in a couple different levels of groups and policy so we can modify it later. So first off, we're gonna create our identity group. So they give you the path, administration, identity management under groups. You've got our endpoint identity groups, user identity groups. So this is technically going to be under our user identity groups. It's not an endpoint, all right? Even though it's technically a piece of hardware, it's getting plugged into one of the edge interfaces. So under the user identity groups, we'll say new, and we'll give it a name of APs, a description, credentials for the APs. We then create an identity. So under administration, still identity management. Notice we went from groups, now we're under identities. So it's not the overall group, just the identity within that group. All right? And you can do this out of order. You can create the group first, and then when you create the identity, you say it's part of that group. So you create this identity, well, just a regular user will say, give it a name of AP, and we create the name, the username, and password. Right here, when we create this identity, that's where we create the same username and password that we created back on our controller. So the controller is going to be handing these credentials out to our APs. It's going to be checking them against the Radius server. If that matches, then yes, we're good. And then, of course, right here under the user identity groups, we add that set of credentials. We add that identity to the identity group of APs. So I can reference that identity group in any kind of policy, any kind of scalable configuration. We then go to the policy set. So under policy sets, we're going to create a policy here. We'll give it a name, port authentication, whatever name you want to give it. And we can see here in the description, policy for switch port 8021X, authentication for access points. Give a good description on this policy so the next engineer knows what you were thinking. We love descriptions. And so the conditions we're matching is we're matching against the device type, and so we can match against the AP when the ISE is profiling the device if it's an access point, and it's wired 8021X. This isn't wireless, this is a wired 8021X authentication. If we expand that policy, all right, so we got our, we'll click on that port off policy. So you got your policy status, the policy set name, the same description and conditions. If you go down here to the authorization policy, what you're looking at is we create a new rule, give it a name, AP Authentication, and the condition, we're matching the identity group. So the identity group we match is that APs, the group we matched earlier, where the action is now permit access. So blowing that up, what does that mean? When a device connects to the switch, 802.1x traffic is allowed. 802.1x, the AP username and password is sent from the switch port off to the Radius server. The switch was pointed at the Radius server. The Radius server is profiling it, saying this is 802.1x traffic from a wired port. Profile it. This is an AP authentication. All right, matches, does that AP group, it's got one identity, the AP, does that username and password that we're receiving match what I've got on that identity? If all that's good, yes, permit access. Open up that switch port, let everything else through. But if it doesn't, if it's somebody who doesn't have that credential, somebody who doesn't match, then we're going to go down to our default action of denied access. So hopefully this has been helpful. We talked a little bit about the why. Okay, wireless is becoming important and protecting against rogue APs, protecting against good ideas. We want to make sure that only the authorized APs are allowed to connect to our network and start transmitting. So point your switch at the Radius server at the switch, make sure the correct credentials are created on both sides. Yeah, you just make sure it's configured correctly, right? That's most networking. And then we're helping to lock down our environment. So let me know if you have any questions. I'll check the meeting chat as well. And this is being recorded, so this will be available in our next database later if you want to review it later.